Today we're going to look at ionic compounds and how you name them and write their formulas. Just as a quick reminder, these are typically made up of a metal and a nonmetal. If you just have one of each, then it's called a binary type, so that's the first ones we'll do. Or you could have a metal and a polyatomic ion, or even two polyatomic ions. So here's some examples of what some of the formulas might look like. Ionic compounds are held together by ionic bonds, and this is where you're going to have one element that donates electrons to another element. The element that's donating is going to be the metal, and it's going to take on a positive charge, so it's called a cation. And the element that receives the electrons is going to be called the anion, or is the nonmetal. And then these are going to also be found in polyatomic ions. So we've talked about some of these before. So we've talked about this one already, so I'm going to skip on over and start looking at writing some formulas. Now the key to compounds when you write their formulas is that they should be electrically neutral. That means that they should have an overall zero charge. So this is why we went over the periodic table and the oxidation states that elements would have, so that you would be able to recognize the charges that the elements would have and then be able to put them together in compounds. So this one's already helping us a little bit. It's giving us some elements. So these are all binary because they're just two elements. It's showing us that sodium, which is in the first column of the periodic table, has a +1 charge. Chlorine, that's in the halogen column, has a -1 charge. If I put these together to make a formula, I only need one of each of these so that the +1 charge and the -1 charge cancel out, and I'll get a 0 overall charge. So this will be the correct formula then for sodium with a chlorine. Now if I look at this next one, I have barium that has a +2 charge with fluorine that has a -1 charge. So in this particular case, I'm actually going to need 2 of the fluorines, or 2 -1 charges, to balance off my +2 charge. To make it have 2, we put a little number down here. This is referred to as a subscript, and it indicates the quantity of each element that you have in this compound. So again, if I kind of look back at this, if this has a -1 charge, then this whole half would have a -2 charge. If barium has a +2 charge, and there's only one of them, so this whole half would be a +2. If I add that together, I'd get a 0 overall charge. So let's look at number 5. You have aluminum that has a +3 charge. That's one you just have to memorize. And then iodine, which is in the halogen group, that has a -1 charge. So if I have this one, I have aluminum, and I put iodine. I'm going to need 3 iodines to balance off my 1 +3 aluminum. So I put my 3 here. Again, just kind of looking back at my charges. If this is a -1 charge, then this half would be -3. If this is a +3, this half would be a +3, giving me an overall 0 charge. Now let's look at one like number 8. So on number 8 we have magnesium that has a +2 charge, phosphorus that has a -3 charge. I can't multiply this one by anything with a whole number to make it 3, or 3 by anything to make it 2 whole number wise. So what I need to do is look for the lowest common multiple, which would be 6. So that means that my magnesium, I would need to multiply this by 3 so that I could get a 6 on this. So that would give me 3 here, +6. Phosphorus, to make it 6, I would need a 2 here. So this will be a -3 times 2, giving me a -6, giving me a 0. Now one thing you can see on a lot of these when you're doing these that need the common multiple, then the charge here actually becomes a subscript on the element before it. So the magnesium gets the 3, and then the 2 comes over here with the phosphorus, and that balances it out. So look at number 10. If you're doing this one, it's got the same situation. We need a common multiple of 6, which means this one would need to get multiplied by 2. This one would need to get multiplied by 3. So my final formula would be nickel with a 2 and oxygen with a 3. Okay, we can look over here. Now if you look at number 18, in this one, we can multiply this by a whole number to make it 4. So that's what we're going to do. So we have lead and oxygen. I'm going to need 2 minus 2 oxygens to get a minus 4. That'll balance off my plus 4. So I'd simply put a 2 here on my oxygen. So you can try some more of these, and if you have questions, we can look at that. Now, naming these is a little more challenging sometimes. When you name a binary ionic compound, you always name the metal just as it is on the periodic table, just whatever its name is. And then the non-metal is going to have its ending changed to IDE. And depending on what element it is will depend on how much of the element name gets removed. So some of them you just have to kind of make it sound like you're not choking when you're saying them. So we'll look at some of these in this next one. All right, so if I'm naming these, the first one, remember I simply named the element just like it is, so that would be barium. And then this is chlorine, but I'm going to take off the INE and just make it a chloride. So I'm changing that ending to IDE. So what do you think you would get on this one? So Na is sodium. Fluorine is my second element, but I want to put the IDE ending, so it would be fluoride. What about number 3? Ag is silver. Oops, sorry. And now this is one you have oxygen, so you're going to take off basically the last part of the name and make it oxide. So again, that one's a little bit one you just have to kind of get used to, so that would be silver oxide. Now let's look at 4 and 5. This is where it gets a little more challenging on these. If you name this one just like we've been looking at, Cu stands for copper. And Br would be bromine, but we take it off and we're going to have bromide. But what would number 5 be? Well, if you look at that one, it would be copper. Erase that, sorry about that. And bromide also, right? But you can see just by looking at their formulas that they're different because the top one has bromine as a single element, and the number 5 has bromine that has actually 2 of those atoms. So this is where we have to indicate the charge of our copper by using Roman numerals. Now just kind of as a quick review on your Roman numerals, of course, you have 1, 2, 3, 4 is IV, 5 is V, 6 is VI, 7 is VII. And you probably will not see any others in these names. So that's about as high as it goes. So if we're looking at these, what you have to do to determine the charge of the copper is you have to look at the charge of the bromine and remember that your compound has a 0 overall charge. So if that is the case, then if I go back up here, I know that bromine is in my halogen group. It has a -1 charge. So this is where going back and looking at those oxidation numbers will be important. If this half of the compound has a -1 charge, then we know that this half, where the copper is, has to have a +1 charge. So that tells me that the copper is a +1 charge. Therefore, I'm going to put a Roman numeral 1 between the copper and the bromine to indicate that this is the appropriate name for this particular compound. So it's copper 1 bromide, is how you'd say that one. If I look at the one below it, number 5, bromine is still -1, but I have 2 of them, so that makes this whole half -2, which means I need to make this whole half +2. So that means this copper has to be +2, and therefore I'm going to need to put a Roman numeral 2 here. So that helps me indicate the difference between the two. So if I gave you this name, you should be able to draw or write the formula based on the fact that the Roman numeral indicates the charge of the metal, or in this case, the copper. So let's try 6 and 7 real quick. So again, if you're looking at these, you can see that you have iron and oxygen in both of them. So they're both going to have iron oxide as part of their name. And what we need to do is figure out what Roman numeral would go here to differentiate the two. So if that's the case, then I see that oxygen, if you look on your periodic table, will have a, let me get rid of a little bit, some of these charges up here real quick. So oxygen, if you look at the periodic table, will have a -2 charge. So that makes this half -2. That means this iron has to be +2, and therefore my Roman numeral will be a 2 here. Now if I'm looking at the bottom one, again, oxygen has a -2 charge, but I have 3 of them, so that makes this whole half a -6, which means I need to make this whole half a +6. I'm not going to use Roman numeral 6 though, because I have 2 of these, so I'm going to take this +6 that I need, divide it by this 2, and that's going to tell me that each iron would have a +3 charge. So my Roman numeral that would go here would be a 3. Now remember, when you're looking at Roman numerals, the only time you need the Roman numerals is going to be when, and I'm going to put that over here on this side, if your element is in group 1A, which is the first column on your periodic table, group 2A, or silver, cadmium, zinc, or aluminum, you do not need a Roman numeral. And the reason you don't need a Roman numeral for these is because they have a definite oxidation state. They don't have multiple possibilities. So everything, remember, that's in the group 1A, if it's a metal, has a +1 charge. Everything that's in the group 2A has a +2 charge. Silver always has a +1 charge. Cadmium always has a +2 charge. Zinc always has a +2 charge. And aluminum always has a +3 charge. These are some that you need to learn. Memorize them and know that those don't need Roman numerals. Okay? Any other metal needs a Roman numeral. So any other metal, if it's not in these 2 groups or one of these 4, you have to put a Roman numeral. So I recommend that you go and try these over here, especially some like 12 and 13, because if you look again, you're going to see that you've got chromium with chlorine, chromium with chlorine. So what you're going to do to differentiate those two is use an appropriate Roman numeral.